Hello students, today we are going to study about ionic or electrovalent bond. Okay, so before starting this topic I would like to say to you the notes are given in the link below. Okay, check that. Now come on, here what is a ionic or electrovalent bond? Till now you were studying that yes, ionic bond or electrovalent bond is a bond in which transfer of electron takes place, isn't it? In the last class 10th, you have studied this only. Yes, here transfer of electron takes place. Now we'll be taking a bit another angle of explaining what electrovalent bond. Here, yes, transfer of electrons are taking place, but here we explain it in terms of what ionization enthalpy and electron gain enthalpy. Electron gain enthalpy we have studied in this third chapter. I have explained you all properly. And I hope so you might be knowing right now. Okay, so ionic bond is what? It is a bond between low ionization enthalpies and the element with a comparatively more negative value of electron gain enthalpy. Okay, so here it is basically saying what? It is a bond between a metal and a non-metal. Okay, metals are what? Metallic elements are what? Which are cationic in nature. What do we mean by cationic in nature? Why they have formed the cations? Because they are losing the electrons, they are giving the electrons. Okay, now what about the anion? Non-metallic elements are known as anion because they are what? They are receiving the electrons, becoming negatively charged. Okay, so here there is an exception of what in this. You can see this, the cation NH4 plus. Here it is non-metallic in nature but behaves as a metallic element, or you can say polyatomic ion. Okay. Now let us study ionic or electrovalent bond with the help of an example. Best example or the common example is of what? Sodium chloride, in which we have studied that sodium gives one electron to chlorine. Okay. So here transfer of electron is taking place, but now here we will be studying with the help of ionization enthalpy and electron gain enthalpy. Okay, so what happens, this sodium, okay, what happens, here electron is being removed from the outermost shell. Now you can understand this, isn't it? So here ionization enthalpy which was required was how much? 495.8 kilojoule per mole. Okay, now this chlorine is accepting the electron. Okay, so what it is doing, which process is going on with what we will be explaining? Electron gain enthalpy. So electron gain enthalpy of chlorine is in a negative sign with minus 34.7 kilojoule per mole. Okay, so now when we sum up this, both the energy, we get the value of 147.1 kilojoule per mole. Okay, so now here what happens? In this formation of bond, okay, the energy was how much? 147.1 kilojoule per mole. But what happens here? Enthalpy of lattice formation, okay, is how much? Minus 788 kilojoule per mole. Okay, so here what happens? Here real energy which is released out. Which energy is released out? This one is released out is greater than the energy absorbed. This means what? Here during the bond formation, as it requires to complete the octet, in that what was happening? Energy was being released out naturally to form the bond. But yes, in order to break the bond, what happens? It requires energy, okay, in order to break it. Okay, so here energy released is more than the energy absorbed. It means what? This is in the favor of formation of the bond rather than the cleavage of the bond into different atoms. Okay, so here when we are saying energy released is more than the energy absorbed, okay, this is explaining what? Lattice enthalpy. Now let us understand this word lattice enthalpy. Actually what happens in this, what is this lattice enthalpy? It is the energy required to break or to cleave the compound into the elemental form, and that happens in case of what? Electrovalent bond. Here we are seeing what metal reacts with a non-metal, isn't it? Naturally, here if I am saying of NaCl, it will be forming a lattice structure because this is a positive ion and this is a negative ion. And yes, the enthalpy is what? The energy. So energy that is required to break that structure, that lattice into its components, okay, in the gaseous forms is known as lattice enthalpy. This lattice enthalpy says about many things, and this can be calculated with the help of different parameters which we will be studying step by step in the next video. Okay, and here what happens, this lattice enthalpy also tells many things about that compound formed. Okay, so this is all for today. Good day. Take care.